morning, students. Next topic is pilot test. So pilot test is the experiment in order to find the load carrying capacity of a pile. Okay. So in this figure, it is the pile whose load carrying capacity is to be found out. So for finding the load carrying capacity of any pile, we are conducting pilot test. Okay. So this is the test pile. So for testing that, we have to apply external load. Okay, so this external load can be applied by using gravity loading, or we can use reaction truss for loading this test pile. Okay. So pilot test means it is the test which is used to determine the load carrying capacity of a pile. And the equipments for pilot test are anchor girder or reaction girder, and this will provide the load to the pile. And there is hydraulic jack, and using this hydraulic jack we are applying load to this test pile, and this is a test pile, and these two are anchor pile. Okay, so this is test pile, that is load carrying capacity of this pile has to be determined, and this is anchor piles. Two anchor pile will be supporting the test pile, and there is dial gauge in order to read the settlement of the pile, and reaction truss if it is truss loading, that is if we are giving load using truss setup, there will be reaction truss. So this is the basic equipments for pilot test. And procedure: the setup consists of two anchor pile provided with an anchor girder or reaction girder at the top, that is there is two anchor pile, and the test pile is installed between the anchor piles as like foundation pile is installed, that is test pile is installed in between these two anchor pile. And the test pile should be at least 3b or 2.5 meter clear from the anchor pile, that is the minimum distance between this test pile and anchor pile is 2.5 meter or 3 times b width. Okay. And the test is conducted after a rest period of 3 days after the installation of sandy soil. That is, if we are constructing the pile on sandy soil, the test is to be conducted after inserting or after constructing the pile, and the test is to be conducted after 3 days. And if the pile is inserted on silty or soft clays, we can conduct the test after a period of 1 month. Okay. And the load is applied through a hydraulic jack resting on the reaction girder or truss, and the measurement of pile movement are taken with respect to a fixed reference mark. We can measure the settlement using dial gauge. And the load is applied in equal increment of about 20% of allowable load. So there is a increment of load, that is 20% of allowable load has to be increased. And the settlement should be recorded with 3 dial gauges. Okay. And each stage of loading is maintained till the rate of movement of the pile top is not more than 0.1 mm per hour in sandy soil. That is, in the case of sandy soil, the loading is maintained till the rate of movement of the pile top is not more than 0.1 mm per hour. Okay. And for clay soil, the loading is maintained till the rate of movement of the pile top is not more than 0.02 mm per hour. Okay, so like that we are maintaining the loading. And under each load increment, the settlement are observed at 0.5, 1, 2, 4, 8, 12, 16, 20 and 60 minutes. That is, we are recording the settlements for each of these time period, that is after 0.5 minute, then after 1 minute, then 2 minute, 4 minute, etc. And the loading should be continued up to twice the safe load. That is, we have to continue the loading up to twice the safe load, or the load at which the total settlement reaches the specified value. Okay, so if the settlement reaches the specified value, we can stop loading, and also if the applied load is twice the safe load, we can stop loading. Okay, and the load is removed in the same decrement at 1 hour interval, and final rebound recorded 24 hours after the entire load has been removed. That is, the load is removed after in the same decrement at 1 hour interval. Then final rebound is also recorded. That is, when we are removing the load, there will be rebound. okay, that it will retain or regain its original strength. So that rebound has also to be recorded after use for that 24 hours. And plot a graph of load settlement and make a curve for loading as well as unloading, which is obtained from pilot test. So this loading will be obtained for the procedure, that for the test when we are applying the load. And after removing the load, there will be a rebound, that is there will be unloading process, and the settlement during this unloading, that is the load settlement curve for this unloading period also has to be noted. So there is two stages, loading and unloading. So the load settlement curve for loading and unloading has to be plotted in the pilot test. So this is the loading curve, that is when we are applying load, this is the variation of settlement with load. And after this point we are removing the load, so that is unloading. So it will reach us, it's the original position, not original one, there will be one there is one restoration for this period. And during this unloading period the settlement will be decreasing. Okay, so this is unloading. So this is the plot obtained using the pilot test. This figure shows typical load settlement curve for loading and also unloading from pilot test. And for any given load, the net pile settlement, that is SN, net settlement is equal to total settlement minus elastic settlement. Total settlement means gross settlement, total settlement, and elastic settlement is a settlement during rebound, that is unloading. Okay, so if you want to find the net pile settlement, it is equal to total settlement minus elastic settlement, and elastic settlement means settlement during rebound. So we will draw net load settlement curve, and this is the net load settlement curve, load and settlement. Okay, and here the safe load is usually taken as 1/2 of the ultimate load, that is safe load is equal to ultimate load divided by 2. And according to IS 2911, the safe load is taken as 1/2 of the load at which the total settlement is equal to 10% of the pile diameter, or 2/3 of the final load at which the total settlement is 12 mm, whichever is lesser. That is, if it is less than this one, we can take this value, or if it is less than this one, we can take this value. That is, safe load is taken as half of the total load at which total settlement is equal to 10% of pile diameter, or 2/3 of the final load at which the total settlement is 12 mm, whichever is less. So that is a safe load according to this code. And according to another criteria, the safe load is 2/3 of the final load, which causes a net settlement of 6 mm. That is, if the net settlement is 6 mm, the load that is 2/3 of the final load for which the net settlement is 6 mm is taken as safe load. Okay, so from this graph we are calculating safe load by considering these criteria. Okay, that is safe load is taken as 1/2 of the ultimate load simply, and according to code the safe load is taken as minimum of these 1 and 2, and by another criteria we can take safe load as 2/3 of final load, which causes net settlement of 6 mm. Okay, so this is the procedure how we are calculating safe load using pilot test. That is, after conducting the pilot test we are plotting a graph between net load and settlement. Okay, so from this graph we can calculate safe load according to these criteria. So this is the equipment which showing pilot test. So this is the test pile whose load carrying capacity has to be calculated, and it is inserted between these two anchor pile, and the distance between the test pile and anchor pile is 2.5 meter or 3 times B, and we are applying the load using any of the equipment and using hydraulic jack also, and we are noting the settlement using 3 dial gauges. Okay, and we are controlling the load increment by considering for which type of soil we have inserted this pile. For sandy soil load increment is different, and for clay soil it's also different. So like that we are controlling the load and calculating the settlement, and finally we are drawing the curve between load and settlement, and from that curve we can calculate safe load by considering some criteria and also from code. Okay, so this is the brief about pilot test. So again, the safe pile load, that is we have explained in this slide, that is result, that is safe pi load is equal to 2/3 of the final load at which settlement is 12 mm, or 1/2 of final load at which settlement is 10% of pile diameter, or half of ultimate load. Okay, so this is the procedure how we are calculating safe load using pile load test. And also net settlement is equal to total settlement minus elastic settlement. Okay, so this pile load test is briefly explained in Aurora textbook, so you should read that textbook, and if you have any doubt, please contact. And this is very important. If in exam it is asked, you should draw a rough sketch of this pile load test arrangement, and also the result by drawing the graph between settlement and load. Okay, so this is about a pile load test. Thank you.